Hey guys, welcome back to my YouTube channel. My name is Ginny Singh. So if you are preparing for the any competitive exams or if you are preparing for the boards also, 12th boards, so this video is very helpful for you. And in the previous lecture, I have completed the types of matrices and the transpose of the matrices, like what are the properties of the transpose of matrices. And I have covered the skew symmetric and symmetric matrices also because if you have not watched them, just go watch them because we are going to use the properties in this video while solving the questions. All right. So let's start with the questions. So this is the third lecture. So first question is given to us. Let X and Y be two arbitrary 3 cross 3 non-zero skew symmetric matrices and Z be an arbitrary 3 cross 3 non-zero symmetric matrix. Then, which of the following matrices is skew-symmetric matrix? In this question, we have to find options are given. Four options are given to us, and we have to find which option will gives us skew-symmetric matrix. Okay. So to solve this question, you must have to understood what is the skew-symmetric matrix and what is the symmetric matrix. In the second lecture, I have discussed these two matrices in the details. So let me just writing in the short. Suppose you have any matrix A, and if you are finding the transpose of this matrix A, you will get the same matrix. Then it is the symmetric matrix. Okay. And if you are finding the transpose of any matrix and you are getting the negative of the matrix, then you can say this is the skew symmetric. I have discussed in the last video. If you have not watched, just go watch and watch the second lecture. I have explained in details there. Okay, so let's check all the options one by one. So first option is given to us. First option is y cube z4. So y cube z4 minus z4 y cube. So we have to find the transpose of this matrix to check whether it is skew symmetric or it is symmetric. If we are getting the same matrix, this one at the end after finding the transpose, if we are getting the same matrix, then we can say it is the symmetric. And if we are getting the negative of this matrix, negative of this matrix will be minus y cube z4 plus z4 y cube. This is the negative of the matrix, right? So if we are getting the negative of this matrix, then we can say this is the skew symmetric matrix. So and we have to remember the transpose properties also. We are going to use them here. So while opening the transpose, we have to write like this z4. So the transpose will come here like as a distributive, and here we are getting z4 y cube and then transpose. Okay. So while we are just opening the matrix which are multiple in multiply, we have to interchange the position. We have remember, like suppose we have CD and we want to find the transpose, we have to write D transpose C transpose. We have to interchange the position. If it is CDE, then E transpose. If CD is, then it will come E transpose D transpose C transpose, like this. Okay. So from here we are getting Z4 transpose y cube transpose minus y cube transpose z4 transpose. Okay. Now here you can see we have a z4 and here transpose. So we can write like this. C. Suppose we have C and we want to find the transpose. So we can say C transpose and then C transpose, like this. And we can write like this also, C transpose square, because we have two C transpose, transpose times C transpose, we are getting C transpose square. So we can see C and this square will come outside 2 because we have 2 times C. So 2 will come outside. And here we have Z4, Z. So this 4 will come outside. So we can write like this, Z transpose, and this 4 will come outside. Okay, like this, these two come here outside, right? So in the same way, this 4 will come outside, and here this 3 come will out. this 3 will come outside. From here we are getting y transpose, this 3 will come outside and this 4 will come outside. Okay. So now the transpose of zt, the transpose of z will be, see, this z is the symmetric matrix. So that means the transpose of z will be the same as z, because symmetric, it is the property of symmetric. If we finding the transpose of the matrix, we are getting the same matrix. So from here we are getting z4, and this y is the skew symmetrics. That means we are getting the negative of the symmetrics while we are finding the transpose. So from here we are getting y cube minus y cube z4, right? Like this. Now if we are writing further, here we are getting z4. This minus will come outside because minus y cube will be minus will come outside. So from here minus z4 y cube minus this minus will this minus will come outside, minus minus will become plus. So plus y cube z4, right? So we can write like this also, y cube z4 minus z4 y cube. So what you have noticed here, from where you have started, you are getting the same matrix. That means the transpose of the matrix is same as the matrix. So it is holding the property of symmetric matrix. So we can say this option A is the option A will gives us the symmetric matrix. So this matrix is we are getting the matrix after finding the transpose of this matrix. We are getting the same matrix. So we can say this is the symmetric matrix. Okay. Next, we have to check the same as for the second option also. So first you can write this solution. Just pause the video and write the solution because I'm going to erase this one. Okay. So write down in the copy. Okay. So let me erase now. You can just pause the video and write it. Okay. Okay. So next option is x44 plus y44. So now we have to find the transpose of this matrix. So we can write like this, x transpose 44 will come outside like by this property I have already explained you, and here again same. So x transpose will be the here minus x because this is the skew symmetric matrix. Okay, so this 44 is the even number. So we are getting, if we are having any even number, so minus will come always as a positive. So here we are getting, again we are getting the same matrix, this one, and here we are getting the same matrix. See, x square is equals to minus, the square of minus x will be x square, right? So it is the even number. So we are getting the positive, right? So in the same as this is the even number, that's why we are getting the positive here. Okay. So you can see we are getting the same matrix. The transpose of matrix is the same as it is. So that again it is holding the symmetric property. So this option B is also holding the symmetric property. So this option B is also not right because we have to find the skew symmetric matrix. So write it in your copy. After this I will erase this. Okay. So move to the third option. third option is Z4 X4 Z cube minus Z cube X4. Okay, so here we have to find the transpose. So this is the as same, it is option A, just some only the elements, I mean x and z are interchanged. So here you will get x4 z cube transpose. All right, and here we are getting z cube x4 transpose. So from here we have to interchange z cube transpose x4 transpose minus x cube, sorry, x4 transpose z cube transpose. Okay, so from here we are getting z transpose 3 will come outside by this property CC, this 2 will come outside, and here again 4 will come outside, and this 3 will come outside. Okay, so from here Z transpose of Z will be Z, because this is the symmetric matrix, and the transpose of X will be negative X, but here it is the power, so minus X 4 will be x4, right, x4. So we can write x4 here and z cube. So you can see the negative of this matrix, the negative of this matrix will be z4 x4 z cube and plus z cube x4. This is the negative of this matrix, so we are getting the negative of this here, and this is the plus. So we can say this is the skew symmetric matrix, because we are getting the negative of this matrix. The transpose of this matrix is negative. Okay, so this is the skew symmetric matrix. So we can say option C is the correct one, because we are here getting skew symmetric matrix. So have you understood how we are getting the skew symmetric matrix? Because this is the negative of the matrix. You can see the negative of x4 z3, this is the negative, and the minus minus plus here. Negative of this one is plus. Okay, so write it down here in the notebook. I am going to erase. Let's check for the option D. So option D is x23 plus y23. Okay, so find the transpose of this matrix. So we are getting xt23 plus yt23. So xt will be minus x23 plus minus y23. So minus x23 minus y23. So here you can see we are getting the negative of this matrix. If we are finding the transpose of the matrix, we are getting the negative of the matrix. So we can say this is also correct option D, because this is also holding the skew symmetric property. Okay. So option C and D both are the correct option for this question. Okay, have you understood this? Let's move to the next video. If next question. If you have not understand this question, just go to the Telegram link I have given below to the YouTube channel. Just go to that link in the Telegram link and ask me the question. If you are having any doubts, like if you are having any doubts like in any step, you can ask me on that link in the Telegram channel. Okay. Okay, so move to the next part. So let's discuss about the some special matrices, as we have already discussed it, but still I'm just recapping it. So first one is orthogonal matrix. So orthogonal matrix means we are getting the identity matrix if we multiplying the transpose of the matrix, and then matrix and transpose matrix. So we are getting the identity matrix. Then we calling them, it is the orthogonal matrix. Next, idempotent is, we are if we are finding the square of any matrix, we are getting the same matrix. Just note it down. If we are finding the square of any matrix, we are getting the same matrix, then we can say it is the idempotent matrix. Involutory matrix means if we are getting the identity matrix after squaring any matrix, we are getting identity matrix, then we can say it is the involutory matrix. And what is nilpotent? Nilpotent, if we are finding the power of any matrix, we are getting the null matrix. Then we can say this is the nilpotent. And periodic matrix is like if we are finding any power of the matrix and we are getting the same matrix after k plus 1. If we are finding any after some period, then we can say that k is the period of that matrix. Okay. Okay, let's do some question. So question is if A, B are two idempotent matrices and AB is equals to BA is equals to null matrix. Null means 0. And then find A plus B. We have to find the A plus B. So we know that idempotent matrix means A square is equals to A and B square is equals to B. If we are finding the square of matrices, we are getting the same matrix. That means that is the idempotent matrices. So in this here we have to find the value of A plus B. So that means if we are finding the A plus B whole square, then if we are getting the same A plus B, then we can say this is the idempotent matrix, right? If we find the square of A plus B, we are getting A plus B, then we can say this is the idempotent matrix, right? So let us check what is the value of A plus B whole square. Just remember one thing, don't use the formula of A square plus B square plus 2AB. Don't use that formula because AB is not equals to BC here, right? So from here we are getting A square plus B square plus AB plus BC. This is the square of this matrix. I am taking the left hand side. Okay. So from here, this AB and BC, sorry, BA. Okay. So this AB and BA is equals to 0. So no need to write here. This will become 0 because this is equals to null matrix. So this will 0. If we are adding any 0 in the matrix, we are getting the same matrix. So no need to write them. So it will become 0. So from here we are getting A square plus B square. As it is already says that A and B are the two idempotent matrix. That means A square is equals to A and B square is equals to B. So from here we are getting A plus B, that is equals to right hand side. Okay. So we can say the option B is the correct answer. So A plus B is the idempotent matrix, right? Okay, move to the next question. Okay, so let A is a matrix of order 2 cross 2. So let us suppose A is the matrix A, B, C, D of 2 cross 2. Okay, 2 cross 2 order such that A square is equals to 0. 0 means null matrix. So we can write like this. Square of this will be, we have to multiply with the same matrix A, B, C, D, that is equals to 0, 0, 0, 0. Okay. We have to find the trace of A. We remember what is the trace of A? Trace of A means we have to find the A plus D. We have to find the A plus D. Okay, that is the trace of A. We have to find the sum of the diagonal. So from here we have to find the sum of the diagonal. That means A plus D we have to find. And it is given A square is equals to 0. Null matrix. So that means when we multiply these two matrices, what we are getting? A square plus BC. We have already discussed how we have to multiply the matrices in the first video. And in the second lectures also we have done some questions of multiplication. So if you have not do, just go and watch them and just understand how we multiply the matrices. So this A will multiply with this A and this B will multiply with this C and we have to add them. Okay. Next, what we are getting? AB plus BD. Okay, CA plus CD CB plus D square. Okay. Now see, this is equals to 0. So from here we are getting, let us take this one and this one first, because we are taking here we are getting B common. So from here we are getting B common. If we take B common from here, we are getting B, and then we A plus D is equals to 0. Okay, from here we are getting this is equals to 0. So we are having two cases. Let understand what are these two cases. I will explain you. See, suppose this A plus D is not equals to 0, but here we are having 0, and let us suppose this A plus D is not equals to 0. That means B must be equals to 0. Okay, then that means B must be equals to 0. Then here we are getting the 0 only, right? If A plus D is not equals to 0, then B must be 0. Then only we are getting here 0. So from here we can say B is equals to 0, right? If if we are supposing A plus D is not equals to 0, from here we are getting B is equals to 0. Okay, and from here take C common. A plus D is equals to 0, and A plus D is not equals to 0, that means C is equals to 0, right? So if B is equals to 0 and C is equals to 0, that means this B and C is 0. That means from here A is equals to 0. If we compare with this 0, let me explain you. A square plus BC is equals to 0, and here BC is 0. That means A is also equals to 0, and here C, B, C is 0 and B is 0, plus D square is equals to 0. That means D is equals to 0, right? So from here we are getting A is equals to 0 and D is equals to 0. Okay, this is the first case. If we are supposing A is not equals to 0, then we can say we are getting A is equals to 0 and D is equals to 0, right? Okay, the next case is, if we are not supposing, in the next case is simple. If we are supposing B is not equals to 0, that means A plus D must be equals to 0. If B is not equals to 0, that means A plus D must be equals to 0, because here we are getting the result 0. So if we are taking A 0 and we are taking as any number to D, then we are not getting 0. So that means we must have to take A is equals to 0 and D is also equals to 0. If we are taking D as a 2, we will not get the whole this one 0, right? So that means we have to take, in all the cases we have to take A is equals to 0 and D is equals to 0. So the answer will be option B. I hope you understand this one. If you have not understand this, ask me in the telegram link. Okay. Okay, next we are going to discuss about the determinants. What is a determinant? How we can find them? So determinant is nothing, it is just a number. How we find that number? So it is defined only for a square matrix. Remember this point, this is very important. Suppose if we are having four options, and all matrices are the like 3 cross 2, 2 cross 3, 4 cross 3, right? Like this matrices, and one is 2 cross 3, 2 cross 2 matrix. And you have asked to find the determinant of one matrix. So you have to find the determinant of the matrix that is defined as for a square matrix. Understood? We can find the determinant of the matrix, which is a square matrix. This is the only model of the determinant. And determinant of matrix A is written as like this. We have to like in the model like this. Like this. We are writing the determinant like this. Suppose we have any matrix A, B, C, D, E, F, G, H, I. So we in the matrix we write like this, right? Like and here we have to write like this. If we are finding the determinant, we have to put the straight lines like this. Okay, then we can say we are finding the determinant of this matrix. Let's do one question. So in this question we have to find the minor of 2 3 in the following determinant. So how we can find the M23? How we can find the M23? What is the M23? So this M23, first find the location of M23. 2 means second row, 3 means third column. Second row and third column, that means this element. So what we have to do, we have to hide this row and this column, hide this row and this column, and then multiply this 1 by minus 1, 1 times minus 1, and here minus, we have to put the minus sign, and this 4 times 2, 4 times 2 will be 8, right? So minus 1 minus 8 is minus 9. So M23 is your minus 9. Okay. How have you understood how we find the minor of any element? So we are getting minus 9. Okay. Now what is the cofactor? What is the cofactor? So cofactor of any element is expressed as the negative of 1 and I plus j and m minor of that any element we are taking. So just remember this formula. This is very important for you to understand the things. Now we have to find the cofactor of C23, this one. So what we have to find, we have already find the minor. So it is minus 1 I plus j and minor of 2 3. This is the formula. See, minus 1 of I plus j m23. So I j is 2 3. So we can write like here 2 3 2 plus 3. So from here 2 plus 3 will be 5. So if it is 5, that means we are getting minus 1 here, and m23 is here minus 9. So from here we are getting plus 9. So from here C23 will be 9. Okay. Now calculation of determinant. What is, how we can find, how we can calculate the determinant? So it is the sum of product of elements of a row or a column with their corresponding cofactors. Remember this thing. We have to find the sum of product, we have to find the sum of product of elements of a row or a column with their corresponding cofactors. So if it is difficult to understand with the definition, so let us discuss with this. So suppose we have any matrix, this A, and we have to find the determinant of this matrix A. So how we can write? We can find D is equals to A, this one, this element, and then cofactor of that element. Then again we have to find A12 and cofactor of this element, and then this factor, this element A13, and then cofactor of this element. Suppose if we are finding the finding, this is finding, we are finding through the row, this one, this is row. We can find through the column also, like this. DA11 C11 plus A21 C21 plus A31 C31, like this. So we have to write the corresponding cofactors. Always write the corresponding cofactors. Corresponding means if it is 1 1, that means we have to take the cofactor also 1 1. Alright. Okay. So next what we have to find the determinant of this matrix. So let us suppose the matrix is A. So what is the determinant of this matrix? So first take the element 1, this one. Take this one. Okay. This one. And the what will be the cofactor of this element? Cofactor is, cofactor of A11 will be C11 will be minus 1, 1 plus 1, and here hide this row and this, I hide this column and this row. So 1 times 2 will be 2, and then minus 2 will be plus 2. So from here we are getting minus 1 square will be 1. So from here we are getting 4. Okay. Next we have to take this 2 plus 2, and then again we have to take the cofactor of this 2. So the cofactor of 2 will be C12 is minus 1 plus 2, because 1 2, right? See 1 2, 1 plus 2, and here hide this column and this row. 3 times 2 is 6, 3 times 2 is 6, minus 4 2 times 2 is 8. So we are getting here minus 1, and from here we are getting minus 2. So minus minus will be plus 2, sorry, plus 2, right? So from here we are getting plus 2, then plus this is 3, and hide this row. Let me write here. C1 3 will be minus of 1, 1 plus 3, and here we are getting hide this column and this row. 3 times minus 1 is minus 3, minus 4. So here we are getting plus 1, because 4 minus 1 raised to the power 4 will be plus 1, and from here we are getting minus 7, minus 7. So now solve this. 4 plus 4 plus minus 27, 21. So from here we are getting minus 21. Okay. So 8 minus 21. So from here what we are getting? 3, 1, minus 13. So the answer will be minus 13. Okay, so have you understood how we have to find the determinant? So this is the bit long process, like how we are finding here this one. It is easy if you will come in the practice. So we can say directly here take plus, minus, plus, because plus, see, 1 plus 1 is square, so that's why we are taking directly plus here. Then here we are taking minus, so here because we are having minus, so minus plus, like this. And then we are finding the hiding the row and hiding the row and column. We can find, if you will do the practice, you will come easily understand, right? Okay, so next is we have to find if this is the determinant and this is equals to x plus iy, then which option is the correct one. Okay, so we have to find the determinant of this matrix. Okay, so do one thing, you can do this in the homework. I am just giving this you question in the homework. Just solve this question in the homework and write the answer in the comment box. I will check it, and if you are not getting, I will explain you in the next lecture. Okay, and the next property is multiplication of a scalar to a determinant. So the scalar number gets multiplied in any one row or a column. That means if we are having any determinant like this, 1 3 1 7 2 1 6 1 2. Okay, okay, so if we want to multiply 2 with this determinant, so that 2 must be entered multiplied with any row or any column. In the matrices we have learned, we have to multiply with the each element of the matrix, right? But in the determinant case, we have to multiply with the row only or in the column only. Suppose we want to multiply 2 here, so this 2 will come here and multiply with this row, okay, or any row or any column. Okay, okay. So next question is, if P is equals to A I J be 3 cross 3 matrices, then and let Q is B I G, where Bij is 2ij, Aij, for R1 is less than I and j is less than 3, the determinant of P is equals to 2. Determinant of P is equals to 2. Then determinant of the matrix is Q, what we have to find. So nothing is given to us. We have only the determinant of P here, and we have to find the matrix Q. So let's find the matrix Q here. So the matrix Q will be here. Bij is of, first we have to assume the matrix A, P. Okay, so let's make the matrix P. A11, A12, A13, A21, A22, A23, A31, A32, A33. Okay, this is the matrix P. So matrix Q will be What will be the Q matrix will be here? Q matrix will be here 2 of I plus j, that means 1 plus 1, that means 2 square, and then A11, and then here 2 cube, that means 1 plus 2, 2 plus I plus j, because here it's given Bij is cube. So from here we are getting A12, and then here we are getting A4, A13, from here A3, A21, A4, A22, A5, sorry, 25, 25, A22, sorry, it is 22, right? So we will get here 4, because 2 plus 2 is 4, right? So 4, and here 25, A23, okay? And here we are getting A24, A31, 25, A32, and then 26, A33, okay? So from here, if we are taking 2 square common from this, okay, from this 2 square common, so from here we are taking 2 square common. Let me check. 2 square we are taking common here, so from here this 2 square will come cancel, and here we are getting only 2, because 2 square we have already taken common, so we are left with the 2, okay, and here we are left with the 2 square, because we have taken 2 square common, right? So here we are taking 2 square common from this row. Okay, only this row, because we are finding the determinant here. So we can take only 2 square common with the row only. Next, we can take the 2 square common with 2 cube. We can take 2 cube common with this row. So here we are taking 2 cube common. So here we are getting 2, and here we are getting 2 square. So from here we can take 2 4 common. So we can take 2 4 common. So here we are getting 2, and here we are getting 2 square. So from this column we can 2 common. We can take 2 common, and from here we can take 2 square common. Okay. So we are having, again we are getting the P matrix. So we can say here 3 4 5 6 7 8 9 10 11. So 2 11, and here we are getting P matrix. So the option B is the correct answer. Okay. So from so today this is enough for the today lecture, and this is the homework question. You can do in the homework and write the answer in the comment box. I will check the answer. Okay, and I will come with the next video, and there I will explain. I will come with the more questions of determinants, and I will explain the more properties also. So I hope you like this video. If you like this video, just like, share, and subscribe, and share with your friends also. So I hope you have a good day. Bye and take care. Thank you.